On this section, we're going to look at arc length and the area of a sector. Very similar to probably a lesson you saw in your geometry class, only this time the formulas are geared towards radian measures, not degrees. So again, if you are given a problem that is in degrees, you need to convert the degree to a radian first before you can plug it into the calculator. So again, remember, an arc length is just the measure of a part of a circle, the outside of a circle. So we know that the arc length or the degree of a circle is 360. So if we were talking about this entire circle, your theta would be 360. If we were to draw two lines here going through the center and cut this almost like a slice of pizza or a slice of pie, it would cut that circle into many different sections. And what we're going to do is we're going to find the arc length of one of those sections. In order to do that, we need to know the radius of the circle and the measure of the angle for that piece of the circle that we want to find the arc length for. Similar to area of a sector, again, the sector is actually the slice of pie itself. So think about when you're trying to find the area of a square or a rectangle, you're trying to find the square footage. You're trying to take the length times the width, or whatever the formula may be. Here's the formula we will use for a circle. R squared pi, or r squared theta, should be somewhat familiar to you from geometry, because I believe for the area of a circle, it's area equals pi r squared. We're not using the pi part, we're using a certain degree because we have only one part of the circle that we're looking at. So this is the formula that we use for area of a sector, and up here is the formula for the arc length. So we're going to use those formulas to help us complete some problems here. So on the first one, it says we're going to use S equals R theta. So we're using the arc length formula. We're given that the arc length is 5 inches and that the central angle is 45 degrees. There's the warning right there. We don't need that in degrees. We need it in radians. So think back to the first trig unit that we worked on. We're going to take the degree and multiply it by pi over 180 so we can convert it to a radian. So in your calculator, you can put 45 over 180, and you can see that this converts to pi over 4. So that's what we're actually going to use for the central angle. What we don't have is the radius, the r. So obviously that's what we're trying to find. So if we plug into this formula right here, our S is 5. We're looking for r, and our central angle is pi over 4. Again, in order to move a fraction, we've got to multiply by the reciprocal. So we have 5 times 4 over pi equals r, which obviously is 20 over pi. But in this case, what's different with this lesson than the last one is we have to actually write the unit of measurement next to it. Remember, radius is a distance. The only distance that was given to us was inches, so our answer must be in inches as well. We're going to use that same formula. This time we're given the arc length and the radius, and we're missing theta, so that must be what we're trying to find. So if we plug in, our arc length is 2 pi equals radius of 4 times, and we're looking for theta. This one's pretty simple. We know we just have to divide by 4. 2 pi over 4 simplifies to pi over 2. And again, our central angle is always measured in radians, so you want to make sure to put radians next to it. On number 3, we're going to use the formula to find the area of a sector. We're given the area, and we are given the radius. So obviously, we're looking for the central angle theta. So we're just going to plug everything in. So our A is 32 equals 1/2 times our radius, which is 3 squared, times theta. Remember, this is the same thing as saying over 1. So 3 squared is 9, and 9 times 1 is 9. So we have 32 equals 9 over 2 theta. And again, just like we saw on number 1, anytime you want to move a fraction, you need to multiply by the reciprocal. So we have 32 times 2/9 equals theta. So 32 times 2 is 64 over 9. And I don't believe that can be simplified, so don't forget to put your radian measurement next to it. And then finally, we're given the area and theta again. We're looking for r. So A is 8 equals 1/2 times, we're looking for r, so we have r squared times theta, which is 2 pi over 3. We didn't have to convert that one because it wasn't in degrees. How do we know? Because there's no degree symbol next to that measurement. All right, so looking at the two fractions here, if you look at the numerators, you have 1 times 2 pi, so you have 2 pi, and then you have the radius squared next to that, over, and then if you look at the two denominators, you have 2 times 3, which is 6. 2/6 can reduce to 1/3, so I'm going to reduce that to pi r squared over 3 before I do anything else. So the first thing we need to do is we need to get rid of this fraction from the r, so we got to multiply by the reciprocal. So we have 8 times the reciprocal, which is 3 over pi. That's going to equal r squared. So that gives us 24 pi, or 24 over pi equals r squared. And of course, how do we get rid of a square? We square root. So we're going to square root both sides, so r equals. Now, it depends on what they want you to write the answer as. If the directions really doesn't show you or tell you how to write your answers, you want to simplify it the best that you can. I'm perfectly happy with you leaving the answer as the square root of 24 over pi. Don't forget your unit of measurement up here. We saw that area was square feet, so our radius would be measured in feet. If they wanted you to write it as a decimal, obviously they would tell you how to round, so on and so forth. But with any kind of worksheet that you're going to do with me, you're allowed to leave your answer in that mode.